The broadcast is now starting. All attendees are in listen-only mode.
Welcome to this webinar. My name is Gino van Stralen and we are going to talk about external links to SCIA Engineer. Or we are going to talk about how to link your own modeling tools and design tools to SCIA Engineer. Now we are going to split up this webinar into two parts. Today we will talk about how to link the design tools, and the next part will be given on April 25th, and then we will talk about how to link your own modeling tools to SCIA Engineer. The audio of this webinar for the participants is muted, so you will not be able to speak to me. You can only hear me. But if you have questions, you can use the question window and ask your questions. After the webinar, I will respond to these questions. The webinar will also be recorded and will be published on the SCIA YouTube channel later this week. Now, the overview of what we are going to see is how to link SCIA Engineer to Excel and to the design forms. But first, we will look at this path here. So these are the different steps that you take when you use SCIA Engineer interactively. So first you start with modeling, and then you can do analysis. Afterwards you are able to see the results, and then you can, inside SCIA Engineer, do design and checks. And this means that you can do the steel code check, you can design steel connections, you can do the design of concrete reinforcement in beams, columns, plates, walls, and shells, all those things. This is inside SCIA Engineer, and at the same time afterwards you can do the reporting. Now this part here, design and checks, here you can also, or you have the possibility to also link your own tools to this part. So instead of using the internal parts of SCIA Engineer, you can also link your own Excel check to SCIA Engineer, read the results from the calculation, do your calculation, and then visualize the result and do the reporting with your Excel calculation. And similar, we can do the same thing with design forms. Now, I will start with the part, the Excel linking. So we are going to link an Excel file to a SCIA Engineer project file, and use the Excel to do the calculations, and then visualize the results afterwards in SCIA Engineer. So how does this work? Now, what we are going to do is we are going to create first an Excel file in which we will use formulas and those things to do the calculation that we want to do. And afterwards, we will link the ESA file to this Excel file. Excel will do the check, so Excel will do the calculation. And in this case, it is a serial calculation on each section of each one, the element. So this means he will do it one by one. Afterwards, what he can do, he will read the results from SCIA Engineer. So he will read internal forces, for instance. Excel reads it, puts it in some cells, and we will define those cells when defining the link between Excel and SCIA Engineer. And what we can do is reading results and also data like cross-section properties, etc., from 0D and 1D elements, so from nodes and from beams and columns. What we can also do is define user-defined additional data. So it is possible that you add data to SCIA Engineer, but your own data. You say, I want to add data, for instance, like just the color of my beam, and depending on that color, you can do one calculation or another calculations, for instance. The calculations, as said, are done using the formulas from the Excel workbook, and we are also going to generate the output, the detailed output in the Excel sheet. SCIA Engineer will then read the results from the Excel and show it in a numerical and graphical output. So he can do it numerically and graphically, and he can also show a detailed output, and in this case it will show a user-defined Excel range. So we as a user, we are going to say this range must be shown, this range from Excel will be shown when we ask the detailed output in SCIA Engineer. Okay, let's use an example to make this a little bit more clear. First step, we are going to make an Excel. It is a very simple example. We will just calculate some elastic stresses in a 1D element. So the focus is on how do we do this, not on how complicated the formulas are. And what we will do is, I will show the Excel. I will open my Excel, and now you see the Excel sheet. And the Excel sheet, or this Excel workbook, has 3 sheets: an input sheet, a calculation sheet, and an output sheet. And in the first sheet, it's organized in this way. What I do is I will read data from SCIA Engineer and put it here in cells. So I say, okay, from SCIA Engineer, I will read normal force, the bending moment My and Mz, and I will also read cross-section properties, and I will put it in cell, in this case D10. I will read W, Y, and Z, put it in cells D11, D12, and I will also read material properties from SCIA Engineer. Notice that these data are in SI, so standard units, SI units. So not in kilonewtons, but here in newtons, meters, and so on. So everything that is exported from SCIA Engineer towards an external application, all data is exported in these standard units in Newton and meters. That means that you will have to make your Excel sheet also you have to make it in such a way that it works in newtons and meters. The calculation is done in these standard units, and afterwards you will have results also in these standard units. But then you can return those results to SCIA Engineer, and SCIA Engineer will show them to the user in the units that are defined in SCIA Engineer itself. So if you set your units to kilonewton or something else, in SCIA Engineer, you will see the results then in kilonewtons. Now in my first page, I have inputted or selected some cells where I put data that comes from SCIA Engineer. On my next sheet, I will do the calculations. So in this case, the calculation part is very simple. I will do the calculation of some elastic stresses. So N over normal force over surface gives me a stress, M over W, WY, MZ over WZ will give me a stress. And I can also say, okay, since I know the yield stress, I've imported it, I can also calculate unity check value. So here I do the calculation. You can have intermediate results here. You can do all the calculations here. And what I do afterwards is I create an extra sheet on which I define my output. So here I define and I organize it a little bit. I put my input data here. I put my stresses here, for instance, and then my result I put there. And in SCIA Engineer, in my project, I will afterwards say, if you want to see a detailed output, then this is the range from A5 to, H20. This range should be exported back to SCIA Engineer and should be visualized in the engineering report. So this can be defined in SCIA Engineer. So this is my Excel sheet where I have those three sheets. Now, in my case, I have used these three sheets, but you're not obliged to do it in this way. You can put everything in one sheet. You can define 20 sheets, doesn't matter. The only thing what is important is that somewhere in your workbook you reserve some cells where you put data that comes from SCIA Engineer. You do your calculation, and how you do it, that's up to you. And somewhere you make some nice output, and you foresee that you can export the range, a certain range, and that range of cells will be shown in SCIA Engineer in the engineering report. Now, step 1 was making the Excel workbook. Step 2 now is linking this Excel workbook to a project in SCIA Engineer. So now I'm going to open my SCIA Engineer, and what I can see here is a very simple project. So I just entered one frame and I did a calculation on this project. So I have already some results, and now what I can do now is use what is called a custom check, which is in our main tree. And this custom check, in this custom check, I can define and link this this Excel sheet. Now, I define it here, and first you can define some names, and which is the name of my check. This is the name what you see here in the tree. So you define some names, but the important part is here at the bottom, where you can say edit, or where you can see edit external file mapping. And when I click here, I can see how the mapping between SCIA Engineer and the Excel file is done. So this data is data that is in SCIA Engineer, and then here you see where it has to be put in the Excel file. So first of all, I ask for the cross-section data, the E-modulus, the cross-section data, the A, the area, the surface. So those two things are put in the Excel sheet, in the Excel file, in this sheet, and on this or in this cell. So here you can see how we send actually data from SCIA Engineer to particular cells in certain worksheets in that file. So we just send those things, and we do the same thing with the internal forces. We also put them into the sheet. And this corresponds to the Excel file. So my internal force on member, normal force, and should be put on cell D5. And I will quick switch back. When I go to my input sheet, you see here cell D5 contains a value, and this value should be the normal force, and that's correct. This is good. Now, this is sending information from SCIA Engineer to the Excel, but we also need a mechanism to get results back from the Excel file into SCIA Engineer, and that are the calculated results. And here we have this, so we have some output parameters from the Excel, which is here the unity check and the stress. And these are in the worksheet calculation in cell D8 and D9. So when going back, it's this worksheet, cell D8 and D9 contain now the results that I'm sending back to SCIA Engineer. And this is all defined here. And now, while doing this, I can run my custom check. So when I now click on custom check, I have at the right size my property window, and this is a similar window as for all results and all checks that we have in SCIA Engineer. So you can say selection is all. I want to do it for a load case or combination. I want to see a unity check or the stress. And I want to see, let's say, the brief output. Let's start with this. Then I can run the calculation. And now we see the calculation in a graphical way. And since I'm looking at global extremes, I only see one value here. But this is normal behavior. I can ask the same thing for section extremes, and now I will get results for each section. I can also ask this as a table result, so also we can see the table results, unity checks and stresses. So I can also preview it in the engineering report. But for the engineering report, let's go to the engineering report. There I can also show my detailed output. So let's open it. So, and this, okay, this is in the cache. So let's recalculate it. Let's refresh it. So now I'm asking this deep detailed output. And now you see that there are, for each beam, there is my stress check for beam, the left beam and the right beam. Yeah, and this corresponds to what I have put in the output part of my Excel sheet. So later I said, okay, I take this range and I put this range of data as a picture picture, because we do it as a picture, we will put it as a picture into the engineering report. And that's what you're seeing here. So let's close this. And go back to the PowerPoint. So linking the Excel workbook was step 2, and then afterwards we get the results back in SCIA Engineer as shown before. So this concludes how you have to proceed when linking an Excel file to SCIA Engineer. This is part 1. And now we will continue with how to link and use design forms to do your own calculations in SCIA Engineer. But first of all, what are design forms? Now, design forms is an environment with a scripting language. And with this environment, we can do calculations, but also we can define the output with formulas and drawings. So this scripting language can be compared to the VBA, the Visual Basic for Application environment in Excel. Now, in SCIA Engineer, we are not using this VBA, this Visual Basic environment, but we use design forms, and that is a C# scripting environment. Now, how does this work? This is very similar to what we do with the Excel link. So, design forms is the scripting environment. And with design forms, we are going to do the check. We are going to do the calculation. In this case, the difference with Excel is that we do the calculations in parallel. So it's much faster here because we do the calculations in parallel. But what we do is basically the same. We will read data from SCIA Engineer into the design forms environment. And the results and data that we can read now are 0D, 1D, and 2D data. So results and data of nodes, beams, but also surfaces. And that is a difference with the Excel link, because in Excel we could only access 0D and 1D. Here we can also include 2D results and data. And similar to the Excel link, we can define user-defined additional data and use this to do the calculations in the design forms environment. Now, in the design forms environment, we can just write formulas and generate short, normal, detailed, all kinds of outputs. In these outputs, we can just show text, we can show formulas, and we can also show graphics. Afterwards, SCIA Engineer will read and show these results again as a numerical or a graphical output. And in the detailed output, we will see user-defined pages with formulas and results, again as a picture here. Now, where is this design forms technology used? Who has used it already? Now, we, SCIA, used it already as an internal development tool for the calculation of the 1D reinforcement. So concrete 1D reinforcement is partially developed with this technology, with the design forms technology. Now, we also have customers who did things with design forms like making a detailed output and a special check for self-designed sandwich panels, or user-defined checks in connections of a special scaffolding. And there are many more examples like this. And we also have extra developers, so external developers who, for instance, did a Eurocode check of glass plates according to the new Eurocode rules. And I call this an extra developer because this can be bought from their website and can be used as a plugin in SCIA Engineer. So they sell it for a price and you can plug it into SCIA Engineer and then use it. Okay, let's show some examples of this technology. So how does it work? Step one is writing the script. So this is a simple example. We are going to calculate again some elastic stresses into the elements. First, we are going to write the script, and this is an example of such a script at the right side. But again, we will do the same steps as in the Excel sheet. So we will first read some information from SCIA Engineer into this environment, and then we will do some calculation. We will write some formulas, and we will then define the output in this environment, in this design forms environment. So reading information from SCIA Engineer is very simple. Everywhere where you see a line starting with IO dot something, we are reading information from SCIA Engineer. So in this case, we start with reading IO dot point from a node in SCIA Engineer, the ID, so the number of the node. And also we will read the thickness of the plate, because we are now doing a calculation on a 2D element, the thickness of the plate in that point. And then we will read internal forces, IO internal force, and X and Y, and so forth. So we will read all those things. And when this is done, we will start calculating W equals H squared divided by 6. And then we will write some formulas for the stresses. Yeah? Now, in this environment, which I will show later, you see this at the left side. This is your scripting. And at the right side of the window, you see this part. And here we will define the layout. So here you see titles. You see the same formulas that we have written at the left side. And this formula can be represented in different ways. So you can say this formula here, I have the variable. I have the formula with the names of the variables. I can visualize the same formulas, but now with the values of the variables and the resulting value. So, and for each formula, you can choose as a user what you want to visualize. So you can say, just show me the resulting value, or just show me the formula with the names of the value. So you have the choice which parts you want to visualize. And then when this part is finished, you just open a SCIA Engineer project, and you can say, listen, I do my calculation, and then I will use this special check. And in the results of SCIA Engineer, we will have this kind of output. So let's now go to SCIA Engineer and show how this works. So let's open the second project, user-defined check. So this is the structure, and it is calculated. So we have results. And now we have here an option which is called integrated design forms. Now I can open this, and this will show me all the design forms that are linked to my SCIA Engineer, so I can use them directly. But now I'm going to go to the check manager on top, because here we can define new checks with a new button. You can create your own new checks, or you can edit existing checks. So in this case, I made some check of my own, and I can open this in the script editor. Okay, he's opening on my other screen, but I will shift it like this. So this is the environment of the design form. So what you see is here, you see this script. So I'm writing as a first line in the script, show me a text or write me a text, and this is the text. So, and that is here the title. At the right side, we immediately see how the output will be. So, and then I define the ID, I define the thickness, and then I put them here again. We say the results are for a given point. At this point, the plate thickness is 6 millimeters. We read the data, so we read some data, and we do not show that. And then we will say, okay, stress is at the top, and this is this thing. And we will just write this formula here. And this formula then will be visualized like this. So you will see the name of the variable, the formula with variables, and the formula again, but with values, and then the resulting value. Now this part can be formatted, so we can align this left, right, we can shift these things, so you can do a lot of things here at the top with how this should be visualized, and that is what we are doing here. Now afterwards, when we calculate, we have here, or when we define all that, we have here the list of variables. And here we can say, okay, this variable, it's one of the doubles that you see here defined. So let's see, let me look here, sigma x top, for instance, that's that one. When I put here result dot and I give it a number 1, 2, 3, 4, that means that I'm sending this value back to SCIA Engineer. So reading information from SCIA Engineer into this environment was done with the IO dot statement, and then some information about which result you want to read or which information you want to get from SCIA Engineer, and then sending back calculated results to SCIA Engineer is done by putting here these results values. Okay, let's close this. And then let's use it. So once I have defined this and added it to SCIA Engineer, I see it here in my list of checks, and I can now use this check. And just like for the other checks, you can here again say, I want to do it for load cases, I want to do it in centers, in nodes, and so on. I want to see one of those results that were sent back to SCIA Engineer, and you see it is quite a list. It was a long list. And I want a brief output with global extreme. So I can now click run, and now it is for a lot of finite elements, but the speed is quite okay because here we are doing things in parallel and we use the full power of your CPU now. And then we see this in graphical form. So we have the graphical output, and we also can ask for table results for the print preview. So these are table results. I can ask for a print preview. So all these things are available, and normal results of SCIA Engineer. And again, I can say, listen, I want to see this in my engineering report, so I can launch the engineering report. And here the engineering report is empty, so the integrated design forms are here in the list. And I can say, okay, I want some, this one, this, my check here. I want to add it. And then I can say for this load case, for the centers, for instance, just like we did before. No, it was E2 top, doesn't matter. I want some brief output, or I want the detailed output. So suppose I want to see the detailed output here, just calculate it, do the calculation. And the detailed output is the output as we had defined it in the design form. So with the formulas, with all those things, that is called the detailed output. So this is what you can see here. And now I did not include pictures, but you can also include pictures and drawings here. And the brief output is the output as we know it here. It falls off the screen here. So, but this is what you can show in the engineering report. Okay. So this is the end of this example. I will show another example, but now without going into much detail, in the sense that I'm not going to visualize the script anymore. This example is a script to do some extra checks in a connection of a scaffolding, a special scaffold. So again, we read internal forces, we read properties of the cross-section, and in this case, we do two unity checks. At the bottom, you see it, unity check 1, unity check 2, and my final result is the maximum value of those two unity checks. So you do you just calculate the maximum value of those checks. Yeah. That is what is inside the script. So let's go to SCIA Engineer. How do you use this? So suppose the script that you already made it. So now I can here say, listen, I want to do a check in this node and in this node. This is part of my scaffolding structure. And this is, by the way, the way how you add your user-defined additional data into this node. So when I click on this, you will see at the right side that one of the things is which members are active now. Now, in this case, we only have 3 members. And these 3 are active. But suppose that we had a 4th member or a 5th member, then we would be able to select or deselect the bracings, for instance, so that they are not included in this calculation. Now, again, to do the calculations, we go to the integrated design forms, and I do this special check in a node. So that is the one that I made. And again, we can say calculate. And now you see the unity check. So the value that is shown is the unity check. And we have summary output. So when we look at the preview, we can see, okay, column 1, these are my internal forces. For the beam, these are my internal forces. Column 2, we do this check between beam and column 1, between beam and column 2, and we just show the biggest, the maximum of both values. So also a simple check with some, a little bit more complicated formulas, but okay. And again, this check is available in your check manager. And this was this special check in Node and can be opened in the script editor just like before. Yeah? Okay, just it opened on my other screen, but I'm going to close it because it just shows some script here, like you can see in the screenshot here. Now this was writing the script. It was the same procedure. We'd have defined the layout, and this layout again can be shown in the output of SCIA Engineer. So you can have this graphical output, which you can also send to the engineering report, and you have the numerical output with the formulas. So this is the end of example 2, and then I come to the conclusions of my presentation. So SCIA Engineer can be used as a standalone application, and when you do this, you follow these steps, these 5 big steps: modeling, analysis, calculation, and then showing the results. You have the design and check with the internal design and checks engines, and you can do the reporting. Now this part, design and check, can be replaced by your own Excel sheets and by self-defined design forms. So this part can be changed or exchanged by these things. And we can use this to also in the engineering report to do the reporting. Yeah? So it is an open and interactive platform where you can reuse your own Excel sheets or develop new checks. Now you see here that something has been grayed out because this part here, modeling, also exists. So you can also use external applications to create your model. So to create nodes, beams, plates, walls, loads and load cases, all those things. And that is done via XML. And this will be treated in part 2 of the webinar, which will be broadcasted on April 25th. So this is the subject of that webinar. I thank you all for your attendance, and I will now check for the questions that have been asked. Okay, I see here a question. Can you use ModCAD worksheets the same way you use Excel? No. So in SCIA Engineer, you can only link Excel and design forms. And another question. Is I do not see the menu where you can choose for the integrated design forms, of course, because this means you can only see this menu when you have the module. So it is a specific module, and if you have this module, then you can you see those options. can we get from the IO the UX, UI node displacements per story? I have to check that, Michaelis. I don't know it by heart. You can have the UX, UI, that's true, but if you can, I do not know if you can export the story results. Another question is, do you have a recommended resource to begin learning this C# scripting? Yes, because the design forums have a help, and it is an elaborated help with each time for each function a small example script. So it is very good for learning this help. Michaelis put the link to it. So it is HTTPS design from SCIA, not help, and so on. How do one obtain the module is contacting your sales representative, or you can ask also to have an for 1 month we can have a free version of SCIA Engineer to do some testing. So you can ask that. Okay. I thank you all, and I will close the webinar now. Thank you very much.